Okay, now for this guy, we are asked to find dy dx, and just to remind you, we could also be asked to find y prime, it's the same thing, for this function, which is e to the y times the cosine of x equals x plus the sine of x times y. Now the thing that should strike you about this thing is we have to use what? Implicit differentiation, right? Implicit differentiation. So the reason why we know that is because we have a bunch of x's and y's kind of commingling, right? We see an x here or y there, that can't fly. So the way that we find dy dx is every time we come across a y and take its derivative, we have to write a little dy dx kind of like afterthought is what I always say. So let's be careful on this though. Going straight left to right, we immediately run into a product rule, right? So we got a little first, second, plus second, first kind of action. And so let's see what we get. We got first, which is e to the y, times the derivative of the second. Well, what's the derivative of the cosine? The derivative of the cosine is negative sine of x, plus the second, which is cosine of x, times the derivative of the first. Now this is where it gets weird. The derivative of e to the y, you see we have y's and x's both in the same place. Not just y's, not just x's, but both. That implies we got to do what? E to the y times the derivative of y. Now what's the derivative of y? You're like, well, it's just dy dx, right? Every time you come across a y and take its derivative, you got to write a little dy dx, okay? Well, that's going to equal what? Let's see. The derivative of x is just 1 plus what? Well, I am going to run out of the room here, so let me see if I can move this over as far to the left as possible. Okay, so what's it going to give us? Well, be careful. We got to take the derivative of the sine of xy. Well, what's the derivative of the sine of anything? It's the cosine of anything times the derivative of the anything. So that cosine is multiplying a whole bunch of stuff, is it not? It's going to multiply what? It's going to multiply first, which is x, times derivative of second, which is dy dx, plus second, which is y, times derivative of first, which is 1. All right? Now that's some really, really nasty stuff. So here's what I'm going to do. I'm going to be brief here, and in the interest of ease, I'm going to call dy dx y prime, but I'm going to write it in a different color so it sticks out. Otherwise, it is easy to lose sight of. All right? So here we got ourselves, I'll just say it is a negative, I'll do all the trig stuff first. Sine of x, cosine of x, e to the y, like that. Negative, oh, sorry, my bad. They're not multiplying, my bad. These first two are multiplying, so my bad. This should be negative just sine of x, e to the y, excuse me, plus what? Well, I'm going to write here that on the outside, this term has a little y prime associated with it. Okay, you can write dy dx, but I'm going to be brief and call it y prime, okay, which is times e to the y times cosine of x, okay? That's going to equal what? On the right-hand side, we got ourselves this 1, which really isn't doing anything, plus, now I'm going to distribute that cosine of xy term. So it's going to distribute to the first thing, which is ugly as sin, right? So it's going to be cosine of xy times x times what? Times dy dx, which is y prime. Again, this guy's just distributing across here and there. We then get, come on, plus that same cosine of the quantity xy times y. Here, I have to write that smaller, otherwise it won't fit. So plus cosine of the quantity xy times y. Holy cow. So what's our goal now? What do? The answer is we got to move things around until we got all the stuff that has a y prime glued to it on one side of the equation, and stuff that does not have a y prime has got to get out of here. All right? So I'm going to move everything that does not have a y prime on the left over to the right. In other words, I'm going to add this thing to both sides, right? Add sine of x e to the y, and I'm going to come over here and just say you're going to add sine of x e to the y. Now, incidentally, though, I also wish to move this guy over here, right? Because he's got a y prime. So I'm going to subtract cosine of xy x y prime, right, on both sides, minus cosine of xy x y prime. So now it's just some nasty algebra. So on the left-hand side, what do we have? We have y prime times e to the y times the cosine of x minus the cosine of the quantity xy times x times y prime. And you'll notice each time I'm trying to write y prime in a different color so we can see it. So that's going to equal what? That's going to equal 1 plus, I guess, all this stuff. Let me see. Yep, 1 plus, let me see, cosine of x, y. Okay, yep, it's hard to see there. It's all cramped, but it's plus cosine of xy all times y. And then finally, we added this new guy to the right, which is plus sine of x e to the y. Yikes. Okay, these things do get pretty nasty, but they're relatively straightforward. Just got to keep everything straight. So finally, what's my goal? My goal is to take that y prime and yank it out. So I got y prime times all this, which is e to the y cosine of x minus cosine of xy x equals 1 plus this gnarly nonsense, which is cosine of xy all times y plus sine of x all times e to the y. Right? Wow. So my last step is to divide both sides by this thing to get y prime on itself. E to the y cosine of x minus cosine of xy times x divided by e to the y cosine of x minus cosine of xy times x, right? So finally, out the door, I'm going to make this look pretty, and I'm going to basically say that y prime is that whole thing on the right. Do we agree? So here, in the interest of space, I'll just say y prime is going to be what? This. All that work to lead us right there, I'll just kind of underline it. And that thing on the right is our y prime.